I wanted to present a quick little review of the terminology. This is so standard, so basic, so fundamental. I want to make sure and do a quick little review so that we have all these notions in our mind so that as we go forward into the graphing of these functions and also the other four functions, that this just needs to be really firmly ensconced in our mind. So we have the functions f of x equals sine of x, g of x equals cosine of x. We're talking about the terminology here. And we have the basic terminology here, the domain, the range, the peak line, the trough line, the axis, and then the amplitude. And then there's one new piece of terminology we'll talk about here as well. Pretty important one. And so once we get all these, we'll throw in this extra piece of new terminology. So for each of these, what I'm going to do here, I'm going to put in, here's another piece of terminology. How about standard interval? So I left that out of my list, the standard interval. What is the standard interval for both sine and cosine? The standard interval is from 0 to 2 pi. We typically include 0 but do not include 2 pi. And so if I'm going to draw a sketch of this, I'm going to draw a reasonably accurate sketch of this, approximation here. So put 1, I always start with 1 and -1. Always start with 1 and -1 on the y-axis. And that allows you to use your finger almost like it's a caliper here. 1, 2, 3. So that's about 3 units. So that's about pi. If that's 1 pi, then double that is about 2 pi. Half of that is pi over 2, and half of that is 3 pi over 2. And now you're good to go. All right? So what is the peak? The peak line is at 1. So I'm going to go f of x is sine of x in blue, and let's see. I'll use this black marker. I'm going to go g of x equals cosine of x in black, and I'm going to put both of these on the same picture. All right. Sine, remember, sine starts at 0. Peak is at 1. And then 0 again, and then trough is at -1, and then again at 2 pi. Now, you'll notice I'm not including 2 pi. In my picture, that's less of an important piece of information. Strictly speaking, this should be an open circle, but that's not usually the big issue involved here. And so if I'm going to draw this, again, a reasonably accurate picture is all you need. Just if the line misses the dot, just make the dot bigger. Same thing here. So that's my reasonable guess at the sine curve. What is the domain of sine? The domain of sine is, now, you got to be careful. All I have drawn is from 0 to 2 pi. I've only drawn the standard interval. But if we're going to ask for the domain of the entire function, the domain of the entire function is all the real numbers. From -infinity to infinity. So the domain of the entire function is all the real numbers, even though the standard interval we draw is only from 0 to 2 pi. If we were to draw from 2 pi to 4 pi and draw that part of the picture, that's still one interval, that's still one period, but it's not the standard interval over which you would draw this. And so what I'm drawing is the standard interval that we understand that even though we're drawing only a piece of it, this continues on in both directions in the same pattern. So the domain is all the real numbers. The range is the part of the y-axis we use. The range of sine of x is from -1 to 1. The peak line, if we had more peaks, we could draw the line through them. The peak line, is it clear? Remember, the graph of a horizontal line is y equals. Y equals that number. So this is the line y equals 1. And the trough line is the line y equals -1. What is the axis? The axis is the x-axis. And the equation of the x-axis, is y equals 0. What is the amplitude? The amplitude is the distance between the peak line and the axis. You could also use the distance between the peak and the trough, but half of it. But it's just as straightforward to say from the peak to the axis, that distance is 1. So the amplitude, this distance, is 1. So the amplitude of sine of x is 1. Now I want to introduce a new piece of terminology. A new piece of terminology are the nodes. The nodes, N-O-D-E-S, node, the nodes. There's more than one, there's nodes. The nodes are the points where the graph intersects the axis. This is a node. This is a node. If we were including it, that would be a node. And so if we had the entire graph, we would have an infinite set of points, the nodes, at 0, pi, 2 pi, next would be at 3 pi, then 4 pi. We would have negative pi, negative 2 pi, and so on in that direction. All right, so the node, N-O-D-E, each node is a point where the graph crosses the axis. So the way to think of it is sine, node, peak, node, trough, node. Node, peak, node, trough, node. All right? And then cosine, we'll do in the black. Now, cosine, remember, starts at the peak, right? So cosine starts at the peak, then node, then trough, then node, then peak. So cosine starts at 1 to 0 to negative 1 to 0 and back up to positive 1. Cosine is kind of like a valley. I think of cosine as being a valley. Sine starts at 0. So I always think of the cosine curve as like the valley. That's very badly drawn. I hope you enjoyed that. Yeah, well. All right. What is the domain of the cosine curve? The domain, if we had the entire graph up here, if we had the entire graph, the domain of cosine is also from negative infinity to infinity. The range goes from negative 1 to 1, so the range of cosine is from negative 1 to 1. The peak line is the same. The connection line for the peaks is the same for cosine as it was for sine. So for cosine, the peak line is also y equals 1. The line that connects all the troughs is again at negative 1. So cosine of x, the trough line is y equals negative 1. The axis is the line midway between the peak and the trough. And the axis is again is the x-axis. The equation of the x-axis is again y equals 0. The amplitude now is the distance between the peak line and the trough line. That distance is still 1 for the basic cosine curve. So for cosine, the amplitude is 1. The standard interval that we graphed over is again from 0 to 2 pi. And we still have peaks. We still have nodes. The difference here is sine starts at a node. It's a node halfway, and it's a node at the end. However, the standard interval of cosine starts at the peak, then node, then trough, then node, then peak. So there are some incredible similarities. In fact, you'll notice all of these are essentially, now we did not specify the nodes, but all of these are essentially, they're the same for both sine and cosine. If you cannot see if you cannot see a whole slew of multiple choice questions here coming on exam day, you're just not looking very hard, because this multiple choice exam just writes itself. Ask you what the peak line is, or what is the domain, or whatever, and it should be very straightforward. So all this information just needs to be standard, not just what the values are, but what the terminology actually means when we say it. So that's a review of the basic terminology. Remember, we have nodes we've been thrown into the mix. So that's the review of the basic terminology of sine and cosine. We have domain, range, peak line, trough line, axis, amplitude, the standard interval, and then the nodes. One last piece. Nodes comes into play. Just cover up the picture. Suppose someone asks, in the standard interval, where are the nodes for the sine curve? Where are the nodes for the sine curve? You should have in your mind's eye, maybe not this much accuracy, but even by now, you should even have in your mind's eye that picture of the sine curve. And you should have this picture of the cosine curve. So if someone says, where are the nodes of the sine curve? You should begin to visualize in your mind without needing to see any information, without needing to look at a graph, without needing to look at a text. Where are the nodes of the sine curve? They're at 0, they're at pi, they're at 2 pi, and if you need more of them, the next one would be at 3 pi, then 4 pi, and so on out. Where are the nodes of cosine? The nodes of cosine, do you see it in your mind's eye? Do you see it? It starts at the peak, then looks like a little valley. The nodes of cosine are at pi over 2, then where's the next one? That's at 3 pi over 2. So it's 1 pi over 2, 3 pi over 2. The next one would be at 5 pi over 2, then at 7 pi over 2. We're talking about odd pi over 2s, odd multiples of pi over 2. And so that kind of information needs to nestle readily in your mind so that you don't need to reference a check sheet, or you don't need to reference this official picture. That needs to be nestled firmly in your mind. And having this basic picture, just like if someone says, what's the basic shape parabola? You know the basic shape parabola. It doesn't have to be perfect, but you know what it looks like. Well, here, what's the basic shape sine curve? What's the basic shape cosine curve? That needs to be part of your mind's eye, what you can see very readily at the drop of a hat.